Okay, we've seen me trying to focus the lens, kind of the laser in real life, but it's a bit difficult to understand what's going on. It takes a bit of explanation. So I've prepared this diagram, which I hope will explain what's happening. Okay, so just explain the diagram first. We've got the metal deck that everything's sitting on. We've got your material on top of that. This blue shape here is the focusing tool, or the height gauge, whatever you want to call it. And then we've got this assembly here. This is what we call kind of the cutting head, which is basically fixed onto the rail that gives it horizontal movement, side to side and front to back. Okay, none of these objects are able to move up and down. It's only the metal deck that moves, and therefore it takes with it your material and the focusing tool. Okay, so this diagram is showing the kind of correct setup. This shape here is the air nozzle housing, and the corner of the housing here is sitting kind of firmly into this elbow. Okay, we're using the low elbow, remember, because of the housing. It pushes everything down a little bit. So we're setting everything up so that there's no daylight between these two objects, and we can and this gives us the correct focusing. So the laser beam, the moment it's generated, it starts to get some width on it. Okay, and so what we need to do is bring that width back down to a point. So the beam comes along, hits the final mirror, this bounces it downwards, it passes through the focusing lens, which is just convex on one side, and that brings the beams to a single point, which is in our case about 35 millimeters down below the lens, and that's where the cutting happens. Okay, so we're moving the deck up and down to achieve this correct positioning. So let's have a look at an incorrect position. So I'm just going to pan this diagram upwards and show you a bad setup. Okay, so here what's happened is a very common error. People look at the shape of the nozzle tip and look at the 45-degree slope on the height setting gauge and think these two should sit like this. They should sit kind of comfortably like that. The problem is that leaves the focusing point floating about a centimeter or so, maybe a bit more, above your material. And so the beams actually cross over each other, then hit the material, and you get quite a broad brown sort of indiscriminate smudge. Okay, so this is where the deck is too low down. Okay, so watch out for that one. It's a very common error. This is way out of focus, and you won't get any cutting done at all. A slightly less common one is where the deck is too high, and so I'll just bring this up again and let you see that diagram. Okay, this can only go, you can only go so high before the deck actually reaches its limit. So this doesn't have such a drastic effect, but you can see here that the beam should really be focusing around about this position. So we're getting a slightly weaker cut. We'll still probably get a cut, but it'll just be weaker and not as sharp. So this one isn't as common, and it isn't as drastic a problem as having the deck too low down. Okay, so watch out for those. Let's just put it back to the last diagram, the original diagram, so you get that fixed in your mind as to how it should be set up correctly. So no daylight between these two items, and the blue object sitting quite snugly in this position. There shouldn't be any movement up and down. Try and wiggle the object if you can. You can pinch it and try and move it up and down, and it shouldn't move. It should be kind of stuck in that position. Okay, hope that's been useful.